Welcome to another session of live coding. And like past Thursday, today is normally focusing on lectures of module 302. And today we are going to talk about times and how they things regards to times in Plutus and on-chain ledger works with each other. And sure, but I just wanted to first announce something that I'm very proud of. We were working on this for a couple of months with it was a joint effort from IOG and of course MLab. But I just want to show you guys, this is the first vulnerability submitted from Gimbal Labs into list of vulnerability that we are publishing and we are making it happen. So at the end of the day, we will be, or we will have some uh, great security compared to other blockchain, which still they don't have it. So it is a very small list right now. We haven't done that much, but I just wanted to share this because it takes many months, and I wanted to be really grateful of my dear teachers, which some of them are here already, James, Adrian, and Piotr, of course. And if you are interested in security and, of course, blockchain research, security stuff, and anything in regards to that, sure, please, you can join us on the certification working group and working on that. We have, I mean, this list is just not complete. We are working on to make it complete, but we have a hope one day actually we will have a dedicated uh, modules and lessons regards to security, regards to each of these vulnerability. For example, this vulnerability I've posted, multiple satisfaction is a very famous one, and actually many famous dApps like MinSwap, Sunday Swap, Liquid Fi, Indigo Protocol, they suffered from this, and there are audit reports regards to that, and they fixed it. So it's not something that we should take it lightly. So those people which are, Haskell guru, Brutus guru, whatever they call themselves, miss some of this logic, and yeah, it is really dangerous. And so that, as we determined, the severity is critical. But yeah, I just wanted to say that this I'm really proud to publish first report from first vulnerability report from Gimbal Labs. I'm going to share the link here as well. So if you
Yeah,
guys want
man, great share. Congratulations, that's really big.
Congratulations to you, my friend. I mean, I wouldn't be here without you guys and without you especially. So I just wanted to be really grateful and just announce it as well. I really feel excited that this thing is getting actually happening. And I should say the only organizations sorry are participating right now, IOG and M Labs. We are asking for other people as well, and they are of course welcome to join. But maybe they are busy with some catalyst stuff.
I
I
thought you
wasn't
were gonna show.
sarcastic,
I
but
thought you were going to show Gimbal Apps utils, but this is even more fresh than that.
actually, gimbal utils, I want to show them. I actually maybe today we will have because I have added them. We have a gimbal utils here, but I don't know. I hope we will have time to showcase you guys what is a gimbal util. But that is not the thing I can announce it. Because that was that is something that I want to show you, like in practice, well, once you see it and see how useful it is. But yeah, guys, we have Gimbal Labs util as well. We have just published it, and you can actually add to your project like that, which there are a set of functions, utilities in order to compile your contract better. I mean, by better, like optimizing and getting more information regards to that and doing some debugging and stuff, which uh, normally it will take some time for you to just find in those functions. But yeah, I hope today we will look into it and use some function as well. But okay, without further ado, let's jump into the our topic. So time. Time works in Plutus and Ledger differently. And the reason is, I mean, we talked about this before and before. Plutus and a smart contract in Cardano must be deterministic. This is the nature of UTXO model, and this is the nature of contracts. But time is not that much deterministic because based on the viewpoint of some people, or actually the time zone, there are time changes. Sure, there are some standard like UTC or some other stuff, or all these time zone standard. But if you want to bring that into code, you have to be more vigilant. Actually, you have to be although deterministic but flexible. So how you should do that? How you can validate your transaction or something related to time inside your contract against something that moves very quickly. The solution Cardano IOG or Cardano Foundation or in blockchain people developed and found was let's be deterministic in Plutus. Let's validate our transaction here. But once we want to submit that transaction, then we will check that time is correct or not. Let me again say it again. So in times of transaction, when the contracts activate itself and that input comes, validate against some stuff and produce some output, everything there will be constant, deterministic. We know what's going on, and same thing like other example of deterministic. We know what is input and we know what is the output. But once you want to submit that transaction, then the ledger stuff comes actually. And we are going to see together how these things work and how something like a deterministic time and then the ledger time actually work with each other and how they understand each other. In order to do that, I just developed a very simple contract so we can play together and step by step going through it. And the contract called Lockbox is just a simple contract that you will send a bunch of UTXO inside it. And after some time that you will determine, like how much time, like, you will determine some redeeming time or deadline time, then you can just unlock those UTXO or funds and receive them. So as simple as that. That's not that much complex. But let's prepare that contract together. I'm going through this step by step. So first, you need to just pull this repository or clone this repository. If you have pulled it, just update the stuff, update the repo. And then after that, you need to go to your Plutus apps. So after going to your Plutus apps, which is why Nix develop and all this stuff we talk about, then come into your PPPL 2023 Plutus template and running Cabal update. And once you do that, after finishing Cabal repel. And since I've done that, I don't want to take your time, I just ran the Cabal repair. And once you are here, we want to compile the contract and, we want to just create the date from our redeemers. And then we'll go to look in the contract. Although we can, if we pass some time, don't worry, we can just change the time and, compile it again. Here, first step would be loading the compiler file, going into compiler. Let me just zoom in this so you can see this better. So it would be lockbox.compiler. And once you do that, there are a set of functions that you can call. And if you come to lockbox, let me zoom this guy as well so you can have a better look into it. So if you come in SRC in root folder, in SRC folder in root directory of that repository, and then going to lockbox, you can see there are several files. Well, let's just now focus on compiler. And you see at top, there is this function, which actually you can do this with other thing as well. But this function creates a folder. That's all. It will create a folder called output, which all your contracts, compiled contracts, and of course, other stuff like datums, redeemer will end up there as well. But as I said, you can create that, but just we want to use Haskell and showcase ourselves, just showing off like too much Haskell. So we just use this function, and it will create that folder here, as you can see, output. And then the next step would be defining these parameters. But what are these parameters exactly? Well, in this contract, the design is we have 3 UTXO. Each UTXO will have an identifier, which are number 1, number 2, number 3. That identifier will be inside the datum of that UTXO. And you can choose any numbers, or if you want to choose anything else, or something else, sure, you're free, but if you want to change this type, you have to change some of the logic inside the contract as well. But if you want to stick with this integer, sure, you're free to choose any number. And this is just not for inconvenient, actually. This is something related to that vulnerability I was showing as well, like multiply satisfaction. And in very short explanation, what is this? It means there are 2 UTXO, and these UTXO doesn't have identification, and the contract spend them, although it should spend one of them, not 2 of them at the same time. But because of the condition was met by the transaction builder, it can be the attacker, it can be anyone, the contract, instead of unlocking or instead of paying, whatever, instead of getting one input and producing whatever output, 1 output, it received 2 input. So it's 2 input or several, maybe it would be 10, doesn't matter, satisfy that. And one of the main mitigation for that would be just make your UTXO unique. Just make your UTXO unique to your contract, by the way, and not unique something to your off-chain, or it by your heart or something. Make it unique to your contract, so your contract can recognize, okay, this is the guy I should validate, and I cannot accept anyone in this transaction. So these numbers are just doing that purpose. Making those 3 UTXO unique. And we have several deadlines. First deadline, second deadline, and third deadline. And the reason is we are going to through some of these transaction building and, figuring out what's going on with these switches, which you guys are going to about to see. And therefore, the idea is the first UTXO, which has the num1 datum on it, will be locked. Will be able to lock, as here inside the contract we say, after the first deadline. Like, maybe you can change this name. I'm sorry if deadline means normally end of something, but So by this logic, we will go through this logic, don't worry, but I just want to start with simple logic. And then the second UTXO will be locked after second deadline, and third UTXO will be locked, locked, not unlocked. I'm sorry, after third deadline. So it's just like that. We've sent 3 UTXO to like a box, which we call a lockbox, and you can just pick up that UTXO or that font or that value if this time has passed. That's all. But that logic, if you want to implement that, you will end up with, I mean, this is kind of the most simplistic way with this logic, which we are going to inside this code as well. So yeah, for compilation, we need to just find this thing. But let's just find out what is this thing. So inside Plutus, we are using POSIX time. POSIX time is an agreed upon time, which starts from a day, like a moment around 40, 50 years ago. And it is very useful if you want to go with this deterministic, because it doesn't care exactly what time zone you are. And it doesn't care where you are. It doesn't care about many other time issues or time problem that your code or other, if you want to develop something regards to time, face. It is deterministic. We know when it has started, and actually kind of we know when it's going to end. I mean, there was some limitation because of the length of the that bytes and bits and the code. One day we will fix it. I don't know, you guys, if you remember back in 2000, there was some issue regards to time. Like if we just move from 1991 to 2000, like word ends, you know, all this stuff. So we might end up with this around, I think 2040 something, POSIX time. But anyway, until then, just don't worry about POSIX time and Cardano and whatever. Until then, we will have enough technology or enough thing just to change. So there is a website, Epoch Converter, or you can just use some the CLI tool to just get the current POSIX time. And the current POSIX time would be right now, it is this guy. And this right now is second counted since that time. The time, as I said, around 50 years ago. Yeah, it was, the time was January 1st, 1970, and the midnight. So after, yeah, exactly. So this is the cause of January 19, 2038. Our contract will get some problem or Cardano or whatever. You know, this is the limitation, and that's a limitation because they were using to a 32-bit integer. So yeah, I don't want to just this is funny, and we will see some catastrophe there. But yeah, so this number was calculated seconds from this time, but inside Plutus here, the POSIX time we are going to use must be in milliseconds, not seconds. So this is, if it is the seconds, we can just copy this, and if we add here, we need to add just 1, 2, 3,000, like or multiply 1,000. So this is the time your contract understand what would be the time of that transaction, or how that validation against time should be. But of course, this is the current time. We don't want that. But for just sake of compilation, I just want to show you this compiling, how this thing compile before I go into the code, because I mean, honestly, I think if I go into the code and other thing, we might miss this stuff. But anyway, if you just want to, like, for example, if you want to add 15 minutes to this, it would be like 9,000 or 900. So if you add 900, because as I said, these are seconds. So 60 to 15, so 600, and then 65, 300, 900 seconds would be 15 minutes. So you can just add here 900 to this number. So your first deadline would be 15 minutes from now. I mean, let's imagine this guy exactly as Steve now. And if you want to add more, you can just simply add more, like 18,000, sorry, 8,800, and then it would be like 30 minutes and so on. So it just by adding this, sorry, this thing, this tree, you can just move up with the numbers. So of course, sorry, move up with minutes. But if you want to go with hours, days, well, you are free to go. But just let's say we have decided about this identification and uniqueness of this UTXO, aka datum attached to them, and this time, and we want to just compile them. So inside again your logbox.compiler, you can just call this function called write logbox script. And this function will compile your contract with these contract parameters and produce an output inside output folder. Let's see if together. So if we can write, and I just with L and tab very quickly, because we have the contract, and you can see this is the contract called Plutus CBOR code. It is a CBOR would be, I should say, it would be a serialized binary of that contract. So it's not the actual code, but one day, I hope, I don't know today, but one day we will, once we start using Gimbal Labs utilities, you'll see that how things are actually working, since you have like from your code to that CBOR, like what steps taken and how this code changes actually. So okay, so now we have that code, we have that contract, and now we can just create our datums, which we want to attach to those UTXO, and of course then the redeemers, which we want to redeem by different step. Once one of those deadline reach, we want to use this guy redeemer. As I said, if you guys remember, redeemers are normally like a trigger. Like we just like for here, we have several conditions, and we want to check one of these conditions, like I want to validate against this, or I want to validate against this, or I want to validate against this. What I want to validate, of course, a transaction. Therefore, in order to just trigger this set of codes and logic, I just need something to trigger, something to tell the contract like, hey, use this guy. And that would be, in our case, redeemers. So let's just write them, or I mean, produce them or build them or make them. So write datum one would be the first datum, and as you can see, it would be very simple JSON, and that's it. This, if you attach this one to a UTXO, your contract will understand, okay, this is unique. Not understand this is unique, but you have to make it unique, because inside the parameter code we have just added, yeah, this is number one, so we want to just match this to number. So we have just told you contract, if you see this guy, this is the one you should validate. Don't care about anyone else, just let's approve, or don't validate, all other UTXO. So let's write other datums as well. Write datum 3, and then let's go with redeemers. Sorry, first claim redeemer, write second claim redeemers, and of course, third one. And if we check the output, we can see that we have all the necessary file for first sending our funds, aka locking them inside contract, and then unlocking them, which would be using of these redeemers when the time is right. Okay, so this is the compilation of this contract, and then if you guys allow me, if you don't have any question or something, I'm going to start talking about the logic of code and how actually these things kind of fit together. So let me check the chat. I don't see it. I hope God understands. Yeah, I hope. We hope so. And actually, maybe by that time, we will reach some quantum related issues. So the time would be your least problem.
That would be a good time to change your keys.
Exactly. And actually, that's the thing. Once we are creating these contracts and we call them like immutable, they are there forever. There are some design patterns that we have to think of. Like, no, actually, these contracts, of course, they exist on blockchain, but we cannot use them forever. How should we do that? How should we create a deterministic code that one day we can be sure that we can just kind of upgrade it, or not even upgrading, we can just start not using it and moving forward with better version, of course, without compromising people's funds and otherwise what's the whole point of this blockchain if we at the end of the day we will compromise them. So yeah, let's start with, if I don't see any question or something, so yeah. Anyway, what is time actually in Plutus? For any reason, Plutus team decided time in Plutus contract must work as a range. So it is not the point at time, or it is just something that you can, again, validate your transaction against it exactly. The nature of the time here, if this is the Plutus documentation, which you can find it in this layer. I'm going to chat again. And if we go down, although we can search it, but I like scrolling more than searching. But anyway, if you go down in Plutus version 1 ledger, of course we can see time. And we see that POSIX time is just an integer. We saw that. We just gave that POSIX time a number because it's received here in types. We define that. We define first deadline, second deadline, third deadline, POSIX time. So POSIX time is just a wrapper. It's just a type alias for integer, just integer. And in Cardano, especially in actually Plutus and Haskell, we have to stick with types because things get really messy if everything is integer or everything is a string, So working with POSIX time actually would be different than if it is just an integer. And it would be good actually because it will stop you for doing some grave mistake. So, but just remember, POSIX times in nature is just an integer. So you cannot, for example, by integer, I should say that it cannot say, okay, like this one point something in like showing some a smaller value of time. No, it is not possible. You have to convert them somehow outside, I mean, off chain, and then provide that time to your transaction, aka contract. But you can see like we have some function in order to create that, like diff millisecond, it will create that. You can just check out some of these function for this, and you can see if you have just a number, you cannot convert them to diff millisecond and then POSIX time. But it doesn't explain that much. But the function and the time actually we are using would be inside this package. Bluetooth.v1.ledger.interval. And I should just remind you, by the way, you might wonder that we are using Bluetooth version 2, why we are still sticking with Bluetooth version 1. Actually, Bluetooth version 1 and 2, of course, there are upgrades, but they are compatible in some sense with each other. And in some sense, I mean, many things we are using in Bluetooth version 2 actually still, they are coming from Bluetooth version 1 libraries. We haven't updated them, or we have, because we don't need that. Like the logic, the code, many things still are completely relevant and useful. So if you see like I'm using Bluetooth version 1 ledger.interval, it doesn't mean it just worked with Bluetooth version 1. No, it means it does work with Bluetooth version 2, hopefully with 3 as well. So I just want to clarify that. But I should just remind you, except API and context, if you want to go with Bluetooth version 2, do not use these packages because they are different. There are things added to this version 2, and as you said, if you see, just if you have these things, and if you have some of these packages, so just imagine we have Bluetooth version 3 as well. If we see there are something under V2, it means that if you want to use it on your project, you can use anything on V1, but not the one under V2. Sorry, maybe I just said it very confusing. For example, here, Plutus v2.ledger API. It means that in your Plutus version 2 contract, you should use this guy. And since we have something similar to this called Plutus v1 ledger.api, it means that you should not use that. I don't know, I'm making sense. So anyway, what is that sign error is asking? This sign in Haskell, actually, you cannot just put on the before a type. You can even put it before a function. Do we have a function here? For example, this. Why this? Oh, yeah. Okay, I have to use the. I have to add something here for. But anyway, you can use this behind your function as well if you want this concept. The concept is a strictness. A strictness means Haskell, in order to reach to a point, let's say point from A to B, it will try to reach to that point. And by the way, I'm calling Haskell or trying, it means like the compilation, like, the code itself. It will try to reach to that point as soon as possible, as best as possible, like as choosing shorter path. And that actually might cause some problem if you want, if in your code. And for example, if I don't put this here, by the way, I haven't seen it, but just for the sake of example, once I want to compile this contract, my contract, the compiler might not actually add this as it is. Like I just wanted to put this as an integer, right? I wanted to put as a number. I wanted to see that actually. We can actually see that in the inside the core, inside the code. But if I don't put that in hypo, if we assume that, the compiler will just ignore it. It just doesn't put that. Or if we try to put this value here, it might put it as is a string, not as POSIX type, or it will put it as something else. So if you want to force your code, your compiler actually, to do as you say to do it, to do as strictly as you are enforcing that to the code happen. Like if there are some steps, like, hey, do not skip this, do not use yours whatever laziness or you have, you will use this sign before those types or function, and then you can be sure that function will behave as you intended, as you designed it, or that type will be inside the code or source, I mean, the binary, at the end of the day, it would be the binary, as, again, you intended to be. So yeah, Martin, I see you unmuted yourself. Do you have a question? Martin, okay. So yeah, I was just saying that, yeah, just be careful about this. If you see something under V2, and if you see something similar on V1, don't use V1, use the V2 version 1. But here in internal, we are still using the version 1. So the time handling, once the logic is simple, it doesn't need to get updated. As far as I know, maybe future it would get updated. But yeah. But what is interval? As I said, Plutus contract works with time, not as a point, but as a range. Interval means range. It's just range. A range means there is a lower bound, upper bound, aka a start and an end. So now you should think of the time once you want to provide to, or once you want to think inside Plutus code as a range, not as a just point at time. Although I'm going to show you like how you can actually, if you want, if you have a point at time and you want to, and you don't know the beginning or you don't know the end, there are functions to help you that. But inside Plutus, time works as a range, and you have to bring that as a range. And you can see there are functions here regards to time. For example, member. What is member? Member means there is a time, there is this like the point of time, and we want to know that this time belongs to that range of time or not. Like let's imagine it's just a list. So member would be like, the time would be like 1, just that point at time 1, and that interval would be from 1 to 10. And the function say, does 1 belongs to the list of 1 to 10? Of course, it means true. Yeah, it does. But if the list is, for example, 10 to 20, it returns Boolean. So interval is always a range. Just remember that. But here in our logic, we didn't create a range. We just wanted to use just point at time, because we know 3 deadline, or that's all. We don't know what would be the end or beginning. We have functions to help us for that. From and to. From actually create a range of time, and to also create a range of time. So if I just use from, let's see what from actually does here. The explanation, from A, and let's say what would be the A here, in our case, would be the first deadline, that integer, remember, is an interval, is a range that includes all the values that are greater than or equal A. So it means actually this function create an interval which lower bound would be this guy.
Hey, Mix, can I pause you for one
And the
question?
upper bound, sure.
Just can you spend a moment just talking about the exclamation point on type definitions when it's a good time to look at that?
To be honest, I don't know. I mean, I answered Eric's question, but I think I don't know if I answered, by the way.
Sorry.
But no problem. To be honest, I'm not sure. I haven't seen a case that if I don't use that inside the like inside the contract parameter, things go badly. Still, I personally, I just want to share my personal experience. I've tested some of the contract. Still, it is. So if I don't put, for example, behind this number 3, the number 3 will end up as number 3. It will end up as an integer. It doesn't end up as something entirely different, which will cause problem for the contract, because we are checking that. You see, your number 1 must be equal with redeemer number. Number 1 must be equal with datum number. But still, I'm not sure. I have seen it on some contracts, but I don't know. Behind the functions, also, I haven't seen that it would compile differently, but maybe it would be safe if you add this thing, if you add them and optimize your contract, because might something in optimization get removed, or I don't know, something. I personally don't know and haven't seen a place that if you do not use that, and actually I should say that inside even datum, you might already man, you can use it. It's like there is no stopping you for doing that. But most cases I've seen it is in parameter, contract parameter, because we are hard coding it inside the contract, and that's all. But I don't know, Adrian, do you know that if we don't use that, something would happen, or don't know?
Yeah, I tried it with using and without using. I didn't saw any difference.
So yeah,
It's the same. So you get nearly the same hash, but not the exact same. But I don't know where the difference is. There's
yeah,
no
exactly.
difference in fees or anything else.
So you will get the same hash, right?
No, it's not the same hash.
Oh, it is not. So yeah, so yeah, you might want to use it, maybe because we get same different hash. It means we are getting it. There is some changes to the code, like to the core, Plutus core, but still I don't know. I'm not sure. Do we need that or not? Yeah. So yeah, I just wanted to show you that this is the thing, but I personally don't use it in my project, but maybe we should do it. Yeah. So yeah, let's go back to our stuff. So from actually create that, and let me see, can we see the source code here? From. So you see that here, from function actually create a range. Let me zoom in so you can see it better. From function create a range of time. Create a kind of is a list. Imagine it is a list, but it looks different. And it takes a S. What was that S? Or it is type A. Type A means it can be anything, but actually we know that it should be POSIX time. It cannot be, but maybe we can ignore those typing stuff. But anyway, it just accept a parameter and an input, And where does this S end up? Lower bound. So this function create a list which it's a start from or integer or time to where exactly? What is this guy? It is this pose INF means positive infinity. Pose INF means positive infinity. So the range actually means from the time until forever. So it cannot be a list, because if it was a list, we would end up with so huge list that it would be impossible for any computer, as far as we know, to just compile it. So in we have some representation, like what is like the positive if, and we can just go through it. What the hell is this? But positive pose INF means positive infinity. And if you want to use something to negative infinity, yeah, we have that as well. So we have two functions. So two function, if it accept a time, a moment or point at time, it means it create a range of time, which is from the negative infinity till to the point of the time you are referring. So by these ranges, we are actually creating a time, what do they call time dilation, but something like time range or contract can understand. And why? Why contract needs time range? Why contract doesn't work with just point of time? Why or contract must like understand a range of time? We are going to see it, and you are going to understand why Plutus contracts needs range of time, and it cannot work with point at time. But just remember that from creates a time which lower bounds would be the deadline, and then it goes to forever, and to create a range of time which come from like the beginning of the universe or whatever, and coming to the exact time we are referencing, we are pointing out. Okay. But do you have guys any question or something? Please tell me. If not, I just want to show you this, that what the hell is contain. I mean, of course, the word is the explanatory, like it's say like I contain, but it means, if I just want to say it means, does this guy contains this? Wait, let me just, maybe I forgot something. Maybe I said just oppositely. I'm sorry. So let me go back to the human readable stuff. Should be here. So contains, so A, which was the range of time we defined, A contains B. So sorry, yeah, exactly, that's what I felt. So the mistake was I was saying that does this range of time exist in this range of time, as I said, the TX info valid range or not, which is wrong. So this actually, I should say, the contain function checks whether this range of time, imagine it is a list, exists inside this range of time or not. So does this guy contain this? Does this guy cover everything? And I should say everything. It is not just part of the portion or not. It must be everything. And TX info valid range means the time we are providing inside the transaction, the time for that ledger guy, if you guys remember. So we want to check that the time is outside of the world. with this function and check does that time exist inside the, does like contain it? Like imagine this is just a list of like 3, 2, and 5, and this is the list of all the positive numbers. So of course this is true because 3, 2, and 5 exist in this list. And same thing for 2. So you see the function looks same. Still, we are saying that the time of the ledger we are providing in transaction is that time, is that range, exists inside this range or not. But as you guys saw, to and from are actually completely opposite. Because from, say, from now to infinity, sorry, positive infinity, and to, say, from now to negative infinity, or I should say from negative infinity till now. Piotr, what do you think?
I have a question. I'm not exactly sure how the Cardano blockchain does this, but like for example, on a Bitcoin blockchain, I think there is like when you submit the transaction gets broadcasted to the nodes, right? And then each node computes the hash. Is it done the same way in the Cardano blockchain, or is it?
No, it is not, and we are going to see it. You know, in because of a smart contract and this concept of EUTXO, extended UTXO, and again because of this time and it has to be deterministic, they kind of separate this concept of validation of time. So we have no validation of time, same as Bitcoin. So if you submit a transaction, the node software, that's CLI, will check it. But before doing that, there is a validation. There is again a validation before that submission. So and we are going to see that validation together. And this validation, this function which I'm talking about, it doesn't happen in Node. It doesn't get compiled or whatever by Node. No, it does happen by actually your system, the whomever create a transaction building.
Okay.
So yeah, but how? Like we are going to create a transaction, validate this against time, and we can do whatever we want, right? If in our local time, we can just change, add, whatever. But how we can submit a transaction that we decided about that time to a blockchain that everyone agree on that time? Here is the issue. Here is the thing that most people are actually confused. And we are going to talk about the relationship between Plutus, aka POSIX time, and a slot number, which is the node. So inside Bitcoin, as you said, we have this guy, ledger time, a slot number. They are talking with each other, synchronizing with each other, acknowledging each other times with different protocols. But this guy wants to come to this guy, and has to. This guy must synchronize itself with this guy. But how? Let's look at it.
Okay. Thanks.
Okay. You're welcome. So yeah, the logic of that, I should just simply say again, remind you guys, the logic of first claim means we can unlock or fund after the deadline, first deadline. The second logic say we want to unlock our second UTXO after the, so I think it is after. Well, let me remember the logic. Yeah, I think it should be before. No, it should be after. Yeah, it should be after. Yeah, after the second deadline. So I just lost my thought, and it should be before the third deadline. And same thing for third claim, it should be after the third deadline. So we will put a time here, waiting some time. I'm going to put around 20 minutes, or maybe, I mean, I don't know, like 15 minutes, because we just want to send some UTXO to this guy. And then we can just unlock them, and then trying this guy and this guy. I'm going to put some 5 minutes difference between these two. So let's do that. Let's come in here. This is the current time. I'm just going to take this guy, come into compilation, and putting this guy here. It is, as I said, it is a current time. So let's add 900 to this guy. I mean, actually here also we have a tool to do that. So if I like right now, this is the time. This, if it is it like GMT? If I just want to add 50 minutes, would put like, let's go with 45, and I'm going to just get this guy. And here we can just copy this guy here from this people, and just copy it here, and then we can just add something more to it. So let me see, this is the guy. So let me add 15, I mean, like 5 minutes to this. Copy that. And same thing, 5 minutes to this. Copying that. And we should be very quick because why? Time is ticking. So write lockbox script. We have it. Then let's craft some transaction. I have my wallet here. There are some UTXO inside it. Let me just create a simple file so we can just temp.tx, and we can, let's say, create our transaction as quickly as possible. We want to send our UTXO to 3 UTXO to the contract. So it would be here. So, okay, this is testnet, input from the wallet, which is this guy. Going to add it here, adding its index, which was 1, yeah. Then collateral, which would be same, and adding index 0, and sending just 2 ADA, and with this guy, lockbox datum JSON, and of course, my own address, which would be cat where I am CD wallet and cat has ADDR. Okay, so now we have the transaction. Let's just, but we need a lockbox address as well. So let's go to output. Let's do, you know what? Let's do everything in output. Output here. Let's create. Let's generate an address, which would be this guy. Generating contract address. As you guys see, time is again kicking. So now we know the address of the contract. So if we just take this transaction, I hope we can just, we have no, let's see, great, no error. So let's just sign and then quickly submit it. Oh, I think I made a mistake. Should have copied. Yeah. So signing key would be, it should be my signing key, which is actually 2 times come up wallet. And then S key, right? Yeah, S dot S key. So let's sign that as well. We got some error. Test it. So what? What's going on? There is some mistake here. Yeah, this should be here. I'm sorry. Please remember. Should have fixed that as well. Yeah, please, guys, remember there should be a slash after sign and discuss problem. I'm sorry, I'm going to fix that. But yep, let's sign that. We just signed it, and let's submit it as well. Transaction was successful. So let's go for another transaction. Okay, it should be 2. Yep, we have that. I think we have it, but let's just check that does that transaction, does that UTXO exist in the contract or not. So let's first cat the contract address, and okay, this is the address. We're just quickly doing that. And then I'm going to, I mean, actually we can just do this as well, why not? So it would be lockbox.addr. So we can see that we have UTXO locked inside the contract, and script data number is 1, which is the datum. We just made that. So let's quickly doing the other transaction and sending those as soon as possible. It just would be this guy very quickly. Everything would be same, except this would be, sorry, would be 2, right? So let's submit that as well. Okay, we got some error. What is the error? Yeah, because yeah, now this hash is, so I should go back. Yeah, the hash of the collateral was different. So for this, yep. Okay, let's do this as well. And submit it. And let's do exactly the same. But let's see that, did we get that? There is a black box here. Nope, still no. But let's see, I'm seeing some question until it looks like POSIX time needs to be written in millisecond in validator script. Yep, we have to, I mean, you have to provide that. I mean, you cannot write that. I mean, you can actually write that. But yeah, POSIX time in Plutus works in millisecond. Okay, now we see that we have the 2 UTXO, one with number 1, another with number 2. Sorry, yep, we just messed up, no problem. Just need to change the, yeah, I sent that UTXO with date on 1. So it is possible to unlock that, don't worry, it is not. So I just want to change this guy, and it should be 2. Copy, paste in everything. Sorry, I think I misclicked that. Let me copy that again. Copy, and yeah. So let's see that, do we get that? This time. Yeah, we have it. And this is the guy. This is the new guy. So integer 2. And let's do the same thing with the third one. I hope we haven't reached, we haven't reached the deadline because I just want to show you an error. But let me put this and changing datum 2 to 3 and submitting these commands. And yep, and let's check out the contract and see, does that exist? Still no, still no. And still no. So let's wait. So let's create, let's craft our transaction for unlock, okay? But for doing that, we need to get something called a slot number. I'm going to go back to it. Don't worry. I just want to let me see that. Yeah. So you see, we have this UTXO as well. Great. But let me just get the slot number, which is the time inside ledger. The time and how we can know the time and what is the reference of time, and we can just keep the node and get that this is the a slot. These are n and whatever, don't care about that, but this is the slot. And these are our seconds. These are in seconds. So I should begin, let me remind you, Plutus works in millisecond, Ledger right now works with second. And one of the reasons actually they separated these two things was in future, we might change a slot number to millisecond, to picosecond, to whatever second, I don't know, to hours, whatever. It is up to us, but we don't want to do that with contracts because we just deploy the contract. We want to go, that contract works at least in theory forever. That's why contract, Plutus, everything deterministic. Here, a slot number, it is not deterministic. It is not that much determined. It might change. It might change to anything in future. And actually, you can see that inside your protocol JSON. I mean, we don't need that anymore. If you are using, by the way, if you are using, I don't know, Node version 8.12, or of course, same thing for CLI. You don't need to anymore provide a protocol version because nodes now are talking with each other. They are doing with P2P and getting all these parameters from each other. So you don't need to provide that, but these are determined there. So yeah, let's just get this, let's craft our transaction. So we just got a slot. And let's, again, let me copy this here. And replace it with this guy, which we were using. So, okay, the input UTXO from our wallet for paying the taxes. So let's query our wallet as well and see what do we have in our wallet. Okay, we have this guy. Adding the index. Then the collateral. Copying it quickly. And index 0. The input from the lockbox. Let's go with first one. So the first one, we can choose either of them. You know, we have two of them, so we can just, let's choose this guy. So it would be this, the index of 0. And we are saying the TX inline datum because the datum we just, you know, deploy, the datum is inside the UTXO. We don't need to provide that. TX script, well, we have it. It is actually here. We just can, because we are running it inside the output folder. We don't need to reference it. And we want to use the first claim redeemer. Okay. And we want to just send it back to ourselves. Okay. Like we just, we want to, I mean, you can send it to anywhere, but for the sake of this example, we want to send it back to ourselves. And the address was the chat wallet, and then this ADDR. So this is the address of our test wallet. That's okay. So the now start number. Just bear with me. Don't worry, we'll go through it. What is invalid before, whatever, no worry. Now start number. Let's again query the blockchain. So this is the now start number. And again, same thing with our address. And let's see what's going on. What would be the result? Okay, we somewhere we got the error. What is the error? Yeah, the error is again, I'm sorry, we should have had several several, I mean not one, I just sorry, we did a grave mistake. I'm going to fix this on the code as well. Yeah, here we see that we don't. So yeah, and why it works? Because we are out of that time. But let's just check it with the third UTX, the third deadline, and see do we get an error or not. So this would be the third guys. I mean, this is the guy. By the way, we just didn't want to we can just unlock it as well, but let's we can submit a transaction, but let's wait. So okay, just changing this to this should be this guy. And did I? Yeah. And the index would be 0. Sorry, I think yeah, this would be the guy. It should be 0. Yeah. And then this should be the third claim. And everything would be same. Let's see that. Do we get error or everything here is true? Yeah, everything here is true. Everything works. And but let's submit that, and it can be submitted as well. And actually, maybe we just passed the time. Did we pass everything? Like, what is the time right now? I don't know. I did a mistake or not. But I think maybe we just messed up something. But let's just submit that. Do we see a submission as well? Let's find it. Yeah, it's submit. So just the time wasn't. We have to come up with better time. So yeah, just forget about all these funds there. No one cares, right? We don't care. We have so many. Yeah, period, yeah, of course. But let's again change these numbers to something like tools. Like, I mean, I'm going to put it as like, 10 minutes or something. So 15 hours. I mean, I'm not sure about this time, by the way. Anyway, let's. This would be Now let's go with some example. Okay, first time would be it should be integer, but that's let me see what did I say. So let's assume this is 0. Let's go with 9. I mean 9, 6, 10 minutes. And oh, 9. I'm not sure. Sorry, what did I do just here? It should be no, it should be 6. Okay, then let's add 5 minutes to it, which means 9, 5 minutes more to it, which means this guy would be, would be 2, and this would be also 2. Okay, let's compile that. You know what happened? Because I have to reload the thing. That's why. Actually, we didn't put any number. You know, that's a mistake I just noticed now. Logparse.compiler. So now, yeah, right script. So actually, if you do not reload the contract, the compile is still now it takes some time because now it just take this number. Now I understand. So anyway, let's just do some stuff. Now some of these again transaction together. There was this 5 here. Well, let's first query your wallet. Okay, one of them came back. Actually, let's use this guy. I mean, never mind, because you have to provide 2 UTXO. And then this guy, let's go back. That okay. This is same, this one same, and should be 1. And let's copy everything and just submit it. Okay, and then oh shit. Sorry if we should have created a new address. I just remembered that. What was the command? Policy ID, no. Command, we just did. So because now you know what happened, it just sent to the old address because we didn't produce the new address. It was just sent to old address. That's why we have to, because we just changed the contract. Therefore, now the address is changed. You have to create a transaction again because that fund we just created was sent to that old contract. Anyway, let's check this. I think. Okay, and I think now we can query the contract address or new one, lockbox, and we should see something which we haven't seen yet. Is it? Yep. Oops. Okay, it is here. So now let's query our wallet again to get this input. Okay, datum 2. Copy. Okay, now let's query it. Yep. Still we don't see it. Okay, we have it now. And then would be 3. Submit it. And then logbox, see that we get it. And then we should just contract changes the core bars, Plutus, we change the picture. Exactly. That's how address generated. They are coming from the hash of the contract. Then okay, we should just take this. Okay, let's see that. Do we have it? Yep, we have it here. Let's query our wallet to get the inputs for spending as fee. Then a collateral, which is then 0. Then the input from the contract. Let's go with the first one. Would be this guy, and the index would be 0, right? And then, of course, changing this, not forgetting to add these forgotten slashes first. So the address would be this address, because this is our address. And now a slot number. Let's query that, getting from the this is the now slot number, so we get the now time. And I think we are ready to see some error. I hope so. If we everything. Yes. Yeah, here I messed this guy. Messed both of them. Sorry. Yep, finally, we saw the error. So we see that the deadline, first deadline, still haven't reached. Therefore, we cannot unlock our transaction, right? So if I just run, I see this thing. But let me show you something really interesting. This was the now time, right? So if if the time works perfectly, yeah, it doesn't work, so you cannot. But let me show you something. I'm going to change this just 4 to 5. It means, I mean, I just changed it, okay? I just changed the now to future. Okay, it gets so many errors because it is too much. But let's go with this guy. Let's make it for 9. So you cannot go so much in future because this means so much in future. But let's go with some in future. Oh, you see? If I run it with the actual time, I get an error because actually it didn't reach to that time. But if I run it with this new time, my transaction is successful. You see? Now there is an issue. I can manipulate the time, although it is not right. And I get the transaction successful. How we should prevent that? how Plutus team Cardano came up with this idea. We just can't change the time, really, and the transaction is successful. This is the thing. So if I just change that time, right? I just change this time. And let's just see if I want to submit that transaction, what would happen? So, oh, now I see you getting error. I see an error right now because, take your Sebastian, because I'm trying to submit a transaction which its time is not correct. That's why Plutus time is different, because whatever you are doing with Plutus happen in the times of transaction building. You can do whatever you want. You can add time, like checking something happen in future, and it works. You can just create a transaction, but actually you cannot submit that transaction. And you might find that maybe, okay, that's okay, reasonable, but is there any use case to that? I just passed 2 minutes from the time now. I don't know. James, do I have a time? Do we have a time? Or should I make a harder stop now?
James left.
Oh, James, well, James left. So, so let me show you something. I mean, let me show you two things that maybe for people who just stick with us right now would be really interesting. So yeah, as you saw, I mean, let's check. Let me clear this guy. So we saw this thing and it doesn't work, right? So because the timing doesn't work. First, let me start with this slot number. What is the slot? Like, I just want to create this idea of inside your mind that how these things works and how you can actually use it for your or your own good, of course, of your own project. So let's get to the transaction, and then you can actually get understanding why that transaction wasn't successful. And I'm maybe actually I'm going to destroy all the things that I was saying to you right now about time. And the reason is this slot number, although it looks time, it is pointing at time. But you know, guys, what is it? It is not time. It is location. It is location. Location of what? You see, inside this transaction building, we've used a switch called invalid before. What does it mean? Okay, it means, okay, if I put this number here, it means the transaction should be invalid before this time. But that doesn't help us that much. You know, we put a deadline and now the transaction failed if we provide the actual time, and now you should use invalid before. You know, like, yeah, at the same time, you should think of future and past and the range. It doesn't make sense, right? But let me tell you, what is this exactly? Invalid before is referencing and telling about a location. But what location? The location of your transaction in blockchain. You see, when I query the blockchain, I see block number 1453030. This is a location. This is a point to somewhere inside the blockchain. And there is another number attached to it, a slot. It represents the time, but it is referencing to a location, which is the block. So here, once you tell to your transaction that, hey, buddy, do not put, sorry, invalid before, it means, hey, Cardano transaction submit. Do not take this transaction and put it in a block before this number. What is this number again? Block number, a location. So this is actually happening inside Cardano blockchain, and actually this is coming from Bitcoin as well. But Bitcoin doing very simply, but here's much more advanced, aka EUTXO. So you are telling, once you are trying to create a transaction, you are specifying where your transaction must be in the series of blockchain. So if I say before, for example, let's say this is block number 1, 2, 3, 4, 5, and 6. If I say invalid before inside my transaction building, I'm saying my transaction, which I want to submit it, must be after, for example, 4. So let's imagine inside this transaction building, instead of this number, you see 4. Cardano Cardano CLI, once you want to submit via Cardano CLI or any other tools, will check this number, and they know what would be the future block number because they know the previous one, and they do not just randomly create it. These numbers are sequenced, they are linear. Same thing with the slots. So block number 9,500 something, we know what would be its slot. What would be the time of that? And as you may know, in Cardano blockchain, each 20 seconds, a new block will come. So we can know that right now, block number 14, 1,450,030, a slot number would be this. The block number 1,550,031, the slot number would be what exactly? Just 20 seconds to this number. It's the plus. So each block move 20 seconds. So we know this number and we know this number. As I said, they are sequence. We know that logic. That's why here we are just saying, hey, do not put this transaction before this block. And if you say, if you are referencing or if you are pointing out to a location, actually you are pointing out to a time as well, to a point of time. That's actually how Ledger verify your transaction. Your Plutus contract is telling to your ledger, or actually maybe telling to you, and you are the transaction builder, where exactly you can put this transaction inside the blockchain. In what block exactly? How? By this time. I know this is maybe too deep, but in order to understand how these things work, you have to understand like why these switches exist. We have another switch as well. What is the next switch? Invalid hereafter. We are telling, hey, this transaction must not be in future block. It cannot. You see that we have just put 60 seconds here. 60 seconds. So now a slot number, let's say, let me copy this guy. So now a slot number, let's say it was 4. We are saying that do not put this transaction before block number 4. or AKA a slot number for something 0, which actually means like today at 15:31:41 actually seconds at 5th of August. Let's imagine this is this, because it is hard-coded. And if I just add 60 to this, it means 3 block after that. So I'm saying that do not put this transaction before block number 4, because block number 3 has, like, if it is like 5, it has 35. Block number 4, 55. Block number 5, more 20 seconds, more 20 seconds. And same thing, this is hereafter. So we are actually saying this is the place you can put this transaction, and you cannot put that transaction somewhere else. Who is telling that? Your contract. How we are telling that? Through this range. That's why we need range inside Plutus contract, not point at time. Because we are validating the position of transaction inside the blockchain, and we are determining that. And blockchain, the name itself says it is a chain, it is a list, it is a range. It has started from somewhere and might end from somewhere. And I hope this create enough image of why we need range, and why actually, and how this Plutus actually talk to Ledger, how they are talking with each other. It's just about block. It's just to say this contract right now, it's just telling what position. And how the contract knows here? We just gave it. These are the location. Yeah, these are the time. Of course, these are the time, but these are the time deterministically attached to a block, and it is not possible to change it. Nodes are doing this. Nodes are just validating their block and the attached number, and of course, any other things which is attached. This is the hash of the whatever it is. They are just checking that. They are not checking the whole stuff again, but they are checking that these position the transaction was saying is really correct. Is this the block I can put this transaction inside it or not? Oh, it is not, because it was saying you cannot put me on block number 3, and also you cannot put me on block number 10. You have to put me in between. Whatever it is, no problem. Yeah, Pietro, what do you think?
I think this is great.
Thank you.
You're a great teacher.
Thank you.
Okay.
I'm learning from best.
Not me. I'm not a great teacher.
Yeah, you were. So go ahead. What do you think? What is maybe bothering you actually in regards to these concepts?
I just wanted to mention for people who may not know that the slot as of now is just 1 second, but this can change in the future. So just keep that in mind, that it can be 2 seconds maybe, but yeah,
Exactly.
It's not set in stone.
Exactly. Yeah, please remember, and because of the explanation I just gave you guys, it doesn't matter that much, because this time we don't care. What we care, what nodes care, and what block the Plutus contract cares is the position, the location of your transaction inside the blockchain. What block, what number. And that number right now has a number attached to it with this style. In future, it would be different number, different system of number, less, more, whatever. But since we say always and always and always, deterministic, determinism, at the end of the day, Plutus contracts cares about this. But they cannot have access to this. That's why in Plutus contract, we will do with this time. But once, as you saw, I just create a transaction to try to manipulate the transaction and manipulate or deceive the Plutus contract, which I failed. Because I was saying you cannot put why that transaction failed, because here I was saying you cannot put, like, for example, let's imagine that if it is invalid before 4, the contract failed or the transaction failed. Why? Because it must reach to 10. I can put this, yeah, it is 10 now. Yeah, well, yeah, it is 10. No problem. And it will be successful. No problem. But once I want to submit it, this guy, Cardano CLI transaction submit, or any service you are using, will compare this number with this number. And he said, wait a minute, we are just on block number 4. And you are saying that you cannot put this transaction to any block less than 10. So sorry, buddy, you have to wait. You have to wait until we reach to a block which has a slot number 10, which is a time in future. Martin, what do you think?
If say it's block number 10,
Okay.
and you put in like invalid before 20, and
Okay.
you submit it, does it stay in the mempool or something in the queue until
it doesn't go to mempool? It doesn't. It will stay at signing stage. It cannot go to that because your node was synchronized. What does synchronized mean? That means you have the latest block, aka latest slot number attached to that block. The latest block right now in your system, in your mempool, is 10. And once you want to say, hey, do not put this on 20, you say, okay, I won't. Don't give me now. Don't give me that transaction now because I don't have it 20. I don't have 20, sorry. It doesn't exist in my mempool. It doesn't exist anywhere. Please wait until we reach to block 20. Then you can just submit it and put it in mempool. And in mempool, other people must accept it because, again, you might in your local machine do something to your Cardano node, to your network, to your timing, I don't know, whatever, to say that, yeah, actually we reached like block 20, but you didn't. In mempool, again, this is happening. The validation of you are doing something in your machine. Let's check out your whatever doing in your machine with others. Let's validate that. Is this guy valid? Is this guy doing correctly something or no? Or is just changing something? We don't know. It's official stuff. Theoretically and actually pragmatically, you can do it. You can just generate blocks by seconds and reach into that. I mean, you know, you saw that there are testnet, like this testnet. This testnet kind of works faster. You can change. You can come up with private testnet. You have the ability to just change any number. You can produce blocks by milliseconds or nanoseconds, but it would be in your machine. And you can again manipulate that and deceive, and you can try to put that transaction inside your mempool. It is possible. I haven't seen, I didn't saw anything similar to that, or actually, but I'm going to show you a use case, by the way, to this. There is a use case, there is an amazing use case for this, but I haven't seen it. But it is theoretical, it is possible. But once that transaction, it is inside mempool, it will fail. And it doesn't go from mempool to the actual blockchain, because again, still you are saying, because you have to send that to a block producer, aka SPO. They should or pool operator, not even SPO. S means single, but pool operator. They have clocks, and the clocks means they have the latest block 10, like, or maybe block 11, block 12. But you are saying, hey, put this on block 20. I said, wait a minute, but you are submitting something for future. And we don't have it. We don't have the damn block to put your things inside that box. Oh, sorry, buddy. I'm going to charge you, because just checking I have this box for putting your stuff inside it or not was costly. So I'm going to use your collateral and your transaction fee.
Yeah.
But what would be use case, guys? In my opinion, it would be the most decentralized, non-custodial, and permissionless use case. Decentralized maybe, or permissionless use case. What? Imagine you have an NFT project, and people will come and say, hey, we want to mint this token or mint this NFT. And you don't have, I mean, you can have the best smart contract for like all this minting, but you don't want to use minting for some reason, or maybe other project. The reason you don't want people send funds from their wallet to your wallet, but somehow you want to make sure that they are the people who are going to send that, or who are going to receive something. So what would happen? Let's imagine this is a transaction for sending money. This is just wallet, right? This is a wallet. Imagine log address, it's another wallet. Okay, that's it, just a wallet. Let me add this invalid before here. What would be the time? This is the time of the minting, imagine, like, or the time you want that fund to be set. Let's say, I mean, let's actually check it. Let's query that. Okay, this is the slot number. I'm going to add this guy, and I'm going to add, for example, like, I don't know, like 999. So this is future. And as actually we learned that it is not possible. So you cannot even send that in from your wallet. Let's check it out. Now, why just talking? Let's check it out. It is not just your contract. Contract actually works as your wallet if the funds are inside the contract. But actually here, your contract, your wallet, validate as well. So, but the validation is different, because the validation is normally just say, are you the owner of this thing or not? So let me UTXO and get this font. Let's try this out. Okay, paste. Transaction successful, right? No problem. But let's see, can I submit that or not? Yeah, I hope that will reach to that, but let's see. I think at 100, no, it should be around 10 minutes from now, at least. Oh, even from your wallet, you cannot, because even in your wallet, you are saying where this transaction must be. Where means which block. But let me show you something. In transaction, submit transaction, I think, let me do it. Well, there was some, yeah, TX view, view, and then there should be decode. I mean, TX. Sorry, I forgot. I see. I'm so sorry. Transaction and TX ID something. Teran. transaction. Okay, TX TX ID, then the TX signed. Oh, where is that? Yeah, TX dot sign. Oh, sorry, I should provide the file TX. I. You see that although we haven't submit our transaction, although the fund still exists in our wallet, we know the hash. We know what would be the UTXO hash in future. What if we have an application that we can store this inside our application? People will not pay anything. And if they spend that UTXO, we see that the UTXO here, and just let me just remove this. So, and if they spend this UTXO, it means they lost their position. They lost their ticket. They lost their chance to mint, to buy, to whatever, without moving one single fund. Without usage of a smart contract, you actually lock their fund inside their. Sorry for this noise. So, and you lost that, sorry, you lock their fund inside their wallet. Until now, well, as far as I know, Eternal, I hope they will provide that. Like you can come to your UTXO list, provide that you can just lock it. You see, so you can be sure that suddenly you won't send that or spend that UTXO. And then once the times happen, that the times come, actually you as a dApp owner can easily start submitting because it is a file like TXI. It just doesn't have to like you cannot submit it because the time hasn't come, because that block hasn't come. You know, the plate is not there, and how you want to put that thing inside that plate. So until that time, you can just store this TX sign, aka I know it's a CBOR. Let me show you. TX sign is just the CBOR. You can just store this, and whenever the time comes, if it was successful, it means they kept their promise. They kept their UTXO, and they deserve whatever they wanted to get. And then if they didn't, if they spend that, naturally, you cannot submit that transaction because that UTXO doesn't exist anymore. And I think this is maybe, I mean, I haven't seen any other blockchain. I'm not that much of knowledgeable in other blockchain, but this is, I think, would be the most permissionless kind of, I mean, like a smart contract-lessness, whatever, form of transaction or trade that you can create transaction for future whenever it times wants to come and wait. And once that time comes, once that the plate, that box was created, the box has a badge on it. And once it is there, you can just submit that transaction, put in that transaction inside there. And until then, these people can get their staking reward. They have full control of their fund. If they want to just withdraw from trade, simply unlock. And now their UTXO is in the game and they can just use it. I haven't seen any application in regards to that. I haven't seen someone is using that, but I think it is a great use case. If there is something that you can, I mean, think of like as planning for, but sure, there is a smart contract where you can just send these funds to the smart contract and, you know, creating these logics, and then unlock it, that all these things, absolutely no problem. But even this is a trustless. We do not trust them. No one is here is trusting anyone. We say that, hey, we craft this transaction, we made sure that even you in your system would not be able to change, to send this to anyone. Because if I just change this number, that hash changed. It is not like, hey, you can put anything you like. So when this is the case, hell, you can just keep your fund in your wallet until the times comes. Martin, still I see your hands are up. Do you have more question?
No, sorry.
No problem, no problem.
Oh,
So yeah,
but
guys,
I
go ahead.
was just thinking about something.
Sure.
Like the time is a range, you say?
Yeah.
Does that mean that if you are coding Plutus and you put a time in milliseconds, that you're actually, the compiler is already making it a slot? Translating it to
The thing
to
is,
a
in
range?
Plutus, in Plutus, everything is inside, everything is as POSIX. But Cardano CLI, these tools convert that to slots.
Yeah.
I don't know how they are doing it, but there are functions, because Cardano CLI is just a wrapper. It's just a scheme around Cardano API. Cardano API is a package. You can find it. It is not a package, it's a series of package libraries. So it's Cardano. There is this guy API. Data. Plutus. What is API? So anyway, yeah, Plutus Cardano API is the guy actually handling Cardano CLI, Cardano node also.
So it is not translated to
and
a
they
slot
are
in the
changing
compiler.
that. Yeah, they are translating that to a slot and putting that and converting, and I mean, actually, it is opposite. Once we put this a slot, where is it? This a slot, Cardano CLI convert this to POSIX time, and then compare it with that POSIX time. But this is Plutus, and what's happening to Ledger is actually checking, that the logic I was telling you, that you are telling to the Ledger where you can put this thing, and if it is 2 in future, which the box doesn't exist, the block doesn't exist, you cannot like it is like 4, and we don't have 5, and we don't have 6, and you are saying you should put it in 5. Well, the transaction failed because you're saying put it in file, and still we are at block number 4.
Yeah. So yeah, a block is described by a left and a right value, and these are integers in time. Yeah.
Indeed. And of course, I mean, I'm just very simplifying. In block, there are so many other things. There are many other hashes, numbers, but I just wanted to say that these slots and these blocks are deterministic. Each of them increase 20 seconds, 20. So 20 is a 20 number adds up always. And then this number is a sequence. There is no randomness. The next block would be 1, the next block 2, 3, something like that. Yeah, that's, and I don't know what is this hash. Is a hash of the whole blockchain. I'm sorry, the whole block, whole transaction, or the transaction. I'm not sure exactly, but yeah. But you see that even we know there's slot in epoch and a slot to end epoch. So even this block knows I am belong to which epoch. So if there is a reward for me, if I should give this reward to anyone, I know this reward was belong to which time. But again, maybe this concept actually very interchangeable, time in blockchain and location. So yeah, guys, I'm sorry it took so long. I hope next week we can take we can again come back to this and sure doing more transaction regards to this. I'm going to update this. Please again forgive me for you see that there are these there should be a slash after this, but there are not. And yeah, and so yeah, if you want to do with the second UTXO, you need to put here after as well, because you see inside the code we were saying it should be between 2 time, aka between 2 location of contract, 2 range of block. And but about the third UTXO, it should be after this one. So for third one, again, we can use invalid before. And also I should say that the logic do not prevent you to unlock, like if the first, if you didn't unlock the first one, you want to unlock the second one, and let's say the time has come, there is no problem, you can do it. Also, I try to add these numbers in parameter redeemer and datum as well, in order to show you some parameterized datums and redeemers, so you can just lose this maybe some fears, like how we can parameterize. And you can see these redeemer also have same thing. We can just add stuff to it, and we see that the datum and even the first one actually same. See that if the redeemer and the datum are same. So in your design for front end or anything, you are actually going to use one object for both datum and redeemer, but your contract understand. I mean, in this case, by the way, in this case, but your contract understand it differently. What are these? We can talk about it later. But yeah, if you have more question, I'm going to remove this guy as well. If you have more question, please feel free to ask. Thank you for your attention and all your question. I know this subject is confusing. Don't worry. It's been confusing. Still it is. And I'm sorry, maybe I'm not the best guy to explain it, but eventually you will understand what the hell is this time and things and block and whatever works together. Yeah, thank you guys. If you have any more questions, please ask. If not, I'm going to stop sharing and then closing. I mean, can we, like, what should we do? I see leave button, but I don't see a stop button. So I assume if we leave the live, everything would be finished. So yeah, see you all. Thank you, Erez. We left. Everyone, take care. Bye.
Thanks.
Thanks. See you.